All right, we have two boxes held by two different tensions. Obviously, this tension, I hope you know, this has a greater tension than that. We'll give them two different names, TA, TB, just because. This is the top tension, TA, bottom tension, TB. This system's at rest, we're told. Find the tension on the top, tension on the top and bottom. So let's make this smaller. Now you're gonna see a new method, a method you haven't seen before. Let me get this up. Why is it? Here we go. All right. Find the top tension. Well, it's really convenient sometimes. If you want to find the top tension, can't we just take these two objects and say they're a single object that has a mass of MA plus MB? I'll show you why that's convenient. This system's at rest. The sum of the forces in the y and x direction is 0. So the up forces, TA, equal the down forces. Now, what are the down forces? MAG plus MBG. So then we see that that's what the tension at the top is. The tension at the top is equal to the weight of the first box plus the weight of the second box, and that's it. Done. Now the second tension, let's get rid of let's erase the circle. Now, when you look at the second box, what you always do is you get what's called tunnel vision. Let's just look at box B, and that's all we care about. So this is the bottom tension. Let's scroll down a little bit. Let's see. Now we'll do it right here. Box B. It's held, but it has two forces on it, TB and MBG. That's it. It's in its state of equilibrium. Let's scroll down a little bit. Okay. So make it smaller. And sum of the forces in the y direction equals 0. And so up forces TB equals the down forces, the weight of the bottom box. And we just ignore everything around it. That's it. Done. So the tension of the bottom string comes about because it's supporting the bottom box, and the tension of the top string comes about because it's supporting the weight of the two boxes. So bottom tension supports one box, top tension supports two boxes. Now it gets a little tougher because now we've got acceleration upward. Find the tension of the top and the bottom. Okay, free body diagram. Free body diagram of B. I like to start at the bottom. So you got B. We get tunnel vision. There's the weight of B. And what are we going to call this? Let's go to the next page. We've got to give these two different names because they're two different tensions. We'll call it TA and TB. Okay, so the bottom box, start at the bottom, that's simple. Call it TB. And we can see the sum of the forces in the y direction equals 0. TB, well, wait a second, hold on. They don't equal 0 because they're accelerating. So the sum of the forces it's going upward. We'll call that positive. Call this negative. So TB minus MBG equals what? MBA. Why? Because these two forces are accelerating one body, the bottom box. Yeah, that's something new for you. So when you do F equals MA, because we're isolating on the bottom box, nothing else exists for us. Remember, you know what the word tunnel vision means? That's what I want you to have tunnel vision once you do this. And so the tension in the bottom box, the tension TB, the tension just above B equals the mass of B, so the weight of B, plus how much B is being accelerated. The more B is being accelerated, the greater the tension, which makes sense to you. If you double the acceleration, this will double, and I can't say that B will double, but it will go up. Okay, so that we do the bottom box. Now let's see, sketch the forces on A. All right, there's certainly we're going to get tunnel vision again. There's TA, there's TB, and there's MAG, the weight. Three forces. There's two that are visible, the tension of TA up, TB down, and these three forces are acting in the box. Remember, we were looking at this with tunnel vision. These three forces are accelerating what? They are accelerating only A. So, positive is accelerating up. The sum of the forces in the y direction equal M A. You know what I forgot to do? Forgot to realize that. Sum of the forces in the y direction equal M A, the mass of A times the acceleration of A. So all we're focusing on is A. So what are the positive forces? Well, it's accelerating upward. It's an upward force of TA minus TB minus MAG, and that all accelerates A. All those forces accelerate the box A. So the tension, let's see, in A, which is what we want to solve for, tension in A, like now I put these two on the other side, equals the tension in B plus the weight of A plus, oh, this is a mistake. Oh, no, that's right. Weight of A plus the acceleration, that's right, of A. The tension in A comes from the tension in B, comes from the acceleration. So the weight of tension in B, tension of A, is equal to the tension in B plus the weight of A plus the acceleration of A. Let's take a look, see if I got that right. I did. Wait a second. Yeah. Yep. Good, 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 good. So there it is. There's the answer. Let's go over that again because all of this is new. We isolate when we do a free body diagram, once your system has more than one body, we've got to isolate each body as if the other one didn't exist. So we isolate A, we say, what are all the forces in A? There's an upward force, the upward tension, the downward force of the tension B, and then the weight of A as well. These are the three forces. And when we solve, we get the following. Now, what is the tension? Okay. Actually, you know what? We're not really done because we could do better than this because we already have the tension of B, don't we? We have it, let's say, the tension of B is right here. So we're really going to bring it all together. So let me make it smaller so you can see. All right. So the tension of A is equal to, what's the tension of B? MBG, the weight of B, MBA, the accelerating force on it, plus MAG plus MA, the acceleration. Well, let's clean this up a little bit because I ran out of room. So we're just doing a substitution for this. So the tension of A is equal to so TV, looking up here, the tension of B is MBG plus MBA, just taking that from above, plus mass of A times G, which is the weight of A, plus the accelerating force on A. Now, let's bring all these things together. TA equals, we can bring the G's all together and see these two G's. We could factor out G and MA plus MB, and then we could bring the A's together plus ma plus mb. The mass of A plus the mass of B. Boy, that's actually the answer, because we wanted to find the tension in terms of the variables given. And there you go. That's that's quite a problem. Is it worth going over? I think I've said quite enough about it. Which cart is slowing down as it travels to the right? They're all traveling to the right. Which one's slowing down? Well, I tell you what, these two are not slowing down. They're moving at constant velocity. Do you know why I know that? Because F, sum of the forces equals zero, so A equals zero. That's what Newton would say. Slowing down, this one's slowing as it goes to the right. This one is speeding up. Speeding up. And that's all I'm going to do here. Hopefully you followed that.